Dear friends, in this episode we are going to learn periodic classification of elements. In year of 1800 about 30 elements were known, but at present we know about 114 elements. All these elements have different properties. So to study about these elements easily, scientists start searching some patterns in the properties to arrange these elements. Early attempts in the classification of elements are as follows. This is the practice to arrange the elements in order out of chaos, meaning arranging elements in the group of metals and non-metals. Chaos means complete disorder or confusing. Furthermore, attempts were made to achieve best classification of the elements. Then comes Dobernier's triad. A German chemist Johann Wolfgang Dobernier in 1817 tried to arrange elements in the group of three elements in each group with similar properties, and he called these groups as triads. Dobernier showed that when we take any triad and arrange its element in order of increasing atomic masses, then the atomic mass of the middle element in the triad is roughly equal to the average of first and third elements of the triad. Dobernier's triads example: lithium, sodium, potassium, calcium, strontium, barium, chlorine, bromine, iodine. In first triad, lithium, sodium, potassium, atomic mass of sodium 23 is equal to Li7 plus K39 divided by 2. Newland's law of octaves. An English scientist, Johann Newland, in 1866 arranged known elements in order of their increasing atomic masses. At that time, he started with hydrogen as first element with lowest atomic mass and ended at thorium as 56th element. Johann Newland observed that the property of every 8 element is similar to that of the first element, and compare this to octaves of music, so he called it law of octaves, and this is known as Newland's law of octave. Newland's octave: hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen. Then fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur. Then chlorine, potassium, calcium, chromium, tin, manganese, iron. Then cobalt, copper, zinc, and so on. Newland's law of octave is applicable only up to calcium, and after calcium it is not applicable, because after calcium every 8 element is do not similar to that of the first element. Newland assumed only 56 elements exist in nature, but later several elements discovered whose properties are very different to get fit in Newland's law of octaves. With the discovery of new elements, Newland tried to fit these elements in octave, so he put two elements in same slot, and Newland also put elements with different properties in same slot. For example, copper and nickel placed in fluorine and chlorine column. Mendeleev's periodic table. A Russian chemist, Dmitry Ivanovich Mendeleev, in 1872 published his Mendeleev's periodic table in a German journal. He arranged elements in the form of table on the basis of fundamental property of elements, that is atomic mass, and also on the basis of similarity of chemical properties of elements, means elements with similar chemical properties are placed together in table. Mendeleev periodic law. According to this law, the properties of elements are the periodic function of their atomic masses. In Mendeleev's periodic table, horizontal rows are called as period and vertical columns are called as groups. You can download or watch Mendeleev periodic table from our website www.chemistrynotesinfo.com. Achievements of Mendeleev's periodic table. Mendeleev periodic table contains some gaps, but Mendeleev predicts that these gaps are fulfilled by elements discovered in future and named these undiscovered elements by placing akka 1 as a prefix to the name of preceding element of the same group. For example, gallium discovered later, but Mendeleev predicted it as akka aluminium. Properties of akka aluminium and gallium. Properties: atomic mass akka aluminium 65, gallium 69.7. Formula of oxide E2O3 and that for gallium Ga2O3. Formula of chloride ECl3 GaCl3. This prediction of Mendeleev proves correctness and usefulness of Mendeleev periodic table. Another achievement of Mendeleev is that many scientists now recognize him as originator of the concept on which periodic table is based, and also when inert gases, means noble gases like helium, neon, argon are discovered, they are placed in separate column without disturbing existing order of elements. Limitation of Mendeleev periodic classification. These given below are the limitation of Mendeleev periodic classification. First, position of hydrogen. No fixed position given to hydrogen, as it behaves like both alkali metals and halogens. Like alkali, hydrogen react with halogen, oxygen and sulfur, and also like halogen, hydrogen exists in diatomic forms and react with metals and non-metals. Isotopes. Isotopes have similar chemical properties but different atomic masses. So isotopes are challenge to Mendeleev periodic law. Prediction of new elements. Atomic mass of elements do not increase in regular manner, so we cannot predict how many elements can be discovered between two elements. Modern periodic table. Henry Moseley in 1913, after performing many experiments, proved that atomic number is more fundamental property than atomic mass of an element. So he prepared periodic table on the basis of atomic number, means elements are arranged in the order of increasing atomic number in modern periodic table. Modern periodic law. According to this law, the properties of elements are the periodic function of their atomic number. In modern periodic table, limitation of Mendeleev classification are removed. You can download this modern periodic table from our website www.chemistrynotesinfo.com. Position of elements in modern periodic table. Modern periodic table contains 18 vertical columns, means 18 groups, and 7 horizontal rows, means 7 periods. In group, elements in a group have same number of valence electrons, means identical outer shell electronic configuration. But as we move downside in a group, number of cells increases. in period. Elements in a period have same number of cells. Also, as we move from left to right in a period, atomic number increases by 1 unit. So, number of valence cell electron also increase by 1 unit. Trends in periodic table. Valency. Number of valence electrons in outermost cell of any atom is called valency of that atom. As we move from left to right in a period, atomic number increases by 1 unit. So, valency of valence electron also increase by 1 unit, but in a group it remains constant. Atomic size. Atomic size is determined by atomic radius. In a period, atomic radius decreases as we move from left to right in a period, because as we move from left to right in a period, nuclear charge increases, which pulls electrons towards nucleus, result in decreasing atomic size or decreased atomic radius. In a group, atomic radius increases as we move from top to bottom in a group, because new cells are added which increase distance between nucleus and outermost electron. Metallic and non-metallic properties. Elements towards left hand side in periodic table are metals, while elements towards right hand side in periodic table are non-metals. Elements which separate metals and non-metals have the properties of the both metals and non-metals are known as metalloids or semi-metals. Example of metals: sodium, magnesium, aluminium, iron. Example of non-metals: sulfur, chlorine, fluorine, bromine. Example of metalloids or semi-metals: boron, silicon, germanium, arsenic, antimony, etc. In a period, metallic character decreases and non-metallic character increases as we move from left to right in a period, because tendency to lose valence electron decreases due to increasing nuclear charge as we move from left to right in a period. In a group, metallic character increases and non-metallic character decreases as we move from top to bottom in a group, because tendency to lose valence electron increases due to increasing valence cells, increasing distance between nucleus and outermost electron on moving from top to bottom in a group. Metals are electropositive as they form bonds by losing electrons, while non-metals are electronegative as they form bond by gaining electrons. In general cases, oxides of metals are basic in nature, while oxides of non-metals are acidic in nature. This is our short podcast on periodic classification of elements. You can download full PDF notes from our website www.chemistrynotesinfo.com for any topic related to chemistry. Thank you to listening this podcast.